Hello, so this is Massachusetts, UK, and today we're going to see if we can write powers with base numbers which are different from e in the form e to the power of some other power. So can we convert an exponential function with a base of 2, 3, 4, 5, 6, so on, into a base of e instead? So that's going to be what we're going to try and do today to see if we can convert these powers of 2, 3, 4, etc. into a power of e's. How can we do that then? So we've got to remember that in order to do this, the natural log, the ln function that we've looked at recently, and this e to the x function are inverse functions. So what does that mean? So that means that when you do e to the power of ln x, because the exponential function there and this natural logarithm function are inverses, that gives you just x there. Because remember the fact that when you apply an inverse function onto a function, this just gives you the variable itself. So that's just a key fact that we need to know. And similar with this one here. So again, the logarithm function and the exponential function, they're inverses, so they're going to give you your variable x there as well. So how can this be useful today? And especially how would this one here be useful? This is really the one that is going to be useful today. So let's look at this then. So if we've got e to the power of ln2, for example, we know that that's just going to be the number 2, because again, we've got the exponential function, and we're putting inside this exponential function this logarithm function of 2. So we just get the variable just using this this result that we got here. The exponential of ln of x is x. So the exponential of ln of 2 is going to be 2. So what does that mean? So we know the number 2 is the same as this number here. So we can say that 2 to the power of x, if we just put the x over here, so I'm going to copy the x and put the x there. So 2 is exactly the same as this number here. So we can say that this is e to the power of ln2 all to the power of x, which in other words, using our rules of indices where we times the powers, if we've got brackets here, we can say that this is just ln2 times by x. So we can write it like this, e to the power of x times by ln2. So we can then therefore say as a conclusion that 2 to the power of x is the same as e to the power of x times ln of 2. Okay, so that's one conclusion that we get. So we've now written an exponential with a base of 2 as an exponential of a base of e. So now we've converted this base of 2 into a base of e, and that's kind of what we wanted to do. I mean, that's kind of the objective of today's video. Can we write these bases with different numbers into a base of e? And we'll see why, especially tomorrow, why that's going to be useful. But let's go on to this example here. So let's say we've got e to the power of ln3. To remember again, the exponential function, applying that to the logarithm function, they're inverses. So that's just going to get you the number 3. So 3 to the power of x is just 3, the number 3, which is the same as this number there. So it's e to the power of ln of 3, all to the power of x. And again, we can say that this is e to the power of x times by ln3 by multiplying that with that there. So again, what can we say here? So we can say that this is, again, a very similar result to what we've got here. So 2 to the power of x is e to the power of x times ln2. 3 to the power of x is e to the power of x times ln3. So a general result is this result here. So when a is greater than 0, so you've got a positive base number, a to the power of x is exactly the same as e to the power of x times ln a. It's a result that you don't necessarily have to learn off by heart, but if you do know that one, it's a good one to know. And especially when we come on to calculus, differentiation, integration, that result will be very, very helpful knowing that result there. So again, it's just like another example. We'll do like a quick example up here. Let's say you've got 5 to the power of x there. Well, this is just the same as e to the power of x times ln 5. So these kind of results are very helpful, as I said, especially with integration differentiation and also in tomorrow's video. So do stay tuned and watch tomorrow's video where we're going to be solving exponential equations and we're going to be using this trick here to do that. So yeah, that was just a summary today of how we can convert exponentials of base numbers, which are different from e, into a base number of e.